Hello, brilliant calculus students. We're going to now revolve around some axis that is not the x or y axis. But we are brilliant calculus students, we can do this. So we have a x is equal to -2. That is where we want to rotate. And we have the function y is equal to x squared minus 1. Well, we know because we're rotating around a vertical axis, we need to do this in terms of x, or we need to solve for x in terms of y. So let us do that real quick. We need to solve for x, add 1 to both sides, so that's just y plus 1 is equal to x squared, and take the square root of both sides, square root of y plus 1 is equal to x. And I'm confident all of you guys can do this. So we now have x in terms of y. That is step 1. So step 2, you don't have to do this, but I'm going to, just for teaching purposes, I'm going to draw our little sketch here of our x and y axis. And so we have our function y is equal to x squared minus 1. Let's draw that first. And then let's say x is equal to 3. We're going to stop at x is equal to 3. Or y is equal to 3, I'm sorry. Y is equal to 3. So we can now draw what this will look like. So if we imagine here for a second, we have our actual line of rotation. This is our axis of rotation. So it's going to kind of go out like this. The same distance. And that's going to be kind of a circle type thing. It's going to be a little cup. We can kind of imagine this thing being rotated around this line. I'll even shade the top because I am totally the best art major. But we need to try and figure out what we need to integrate here. Kind of have an idea of what it's going to look like. It's going to be some kind of gumdrop, I guess, some kind of cup around this line y, around this line x is equal to -2. So if we know this line right here. This is just y plus 1. This is our x. This is x. But we need this distance right here. We don't need x. We need x plus this distance. We need to find this distance instead. And what is this distance? Well, this is x is equal to -2. So this is just x plus 2. So when we take our ring that we're going to spin around, the radius here is actually x plus 2. So if we wanted to find this tiny area of this particular disk, the area is pi times x plus 2 squared. Because we have to add this extra distance here. So now we can do this in terms of y, because we need this in terms of y. And I'll just also account for our volume by saying times r dy. So we can pull out a pi. Let's just integrate from, this is x is equal to -1. I'm sorry, y is equal to -1. Y is -1. So y is equal to 3. So that will be our bounds of integration, -1 to 3. And then we're going to go from the square root of y squared plus 1 plus 2, just substituting our square root of y squared plus 1 in for x. And then we're going to square that. And we are doing this with respect to y. We are adding up these tiny disks, these tiny rings in the y direction. And this one is a bit harder than some of the ones we've done in the past, but what you would do here is you would probably just expand this binomial, saying this is going to be y squared plus 1 plus 2 times ab squared, or 2 times ab, so that's 2 times the square root of y squared plus 1, and then plus 2 squared, which is 4, and then you would integrate this, and I'm certain all of you guys can do that. Alright, let's try and find, let's go about the x-axis here, but we're going to try and find the volume of this little shape here. So we can kind of imagine for a second trying to rotate this thing about the y-axis, or I'm sorry, the x-axis. My brain is like on strike today or something. So it's gonna look something kind of like this part, right? You can kind of imagine, and then we can do that part. We can imagine trying to rotate this around the x-axis to an extent. And then let's say all we really want is this area that's rotated. Because this little ring right here is carved out. So what we're actually going to have is we're going to have this kind of shape like this. We're going to have this circular shape, and we're going to have this part removed. We could subtract this inside area. So let's do that. So what we're going to do is we're going to find the area of the full thing by saying pi r squared, or the volume of it by saying pi r squared times dx. Because we're going to kind of imagine these as little disks with a thickness of dx. So we're going to calculate the volume by just saying pi. We're going to look at this outer function first. That is the square root of x. I'll do that in blue so you can just kind of see. This is the square root of x. This is the square root of x. We're taking the outside function and we are going to square it because we are finding this area, pi r squared. This is our little thing. Now we need to find this area. This area, we can do the same thing by saying, all right, what is this little r out to some radius? Well, this is just the function y at that point, that is x. So we could just say, we could just subtract the same integral. Or we could subtract basically a very similar integral, not the same, just of y is equal to x. We're just subtracting this circle. And we have to square it because it's It's trying to find the pi r squared. And you can kind of streamline this by just saying pi times the integral of x squared squared. The square root of x squared is just x minus x squared dx, multiplying the dx by both of these things. So we kind of have to do it like this. And where do these points meet? We want to find the bounds of integration. So we would have to say x is equal to the square root of x. The x is equal to the square root of x. We could square both sides to get rid of that square root. So x squared is equal to x. And then we could do this with some fancy algebra rules, subtract x from both sides. So x squared minus x is equal to 0. We could factor out an x. And I know all of you guys could most likely do this, but I'm just showing you so that you can kind of work this out. And the zero product property says that multiplying, if this is 0, then we can say any number times another is 0. So this x will be 0. So they will meet at 0, and when x minus 1 is equal to 0, which is just when x is equal to 1. So this intersection point is actually at x is equal to 1. So our bounds of integration are at 0, 1. And then we could do our power rule, add 1 to the exponent, divide by that exponent, and start substituting in values. And I'm certain you all are capable of that, so I'm not going to show you how to do that.